Stop playing. Okay. Right. This is MATS topic. Are you using a brand new notebook for MATS or you combine with MATS?
Combine maths.
Cannot
Oh.
Brand new book please. No combination. MATS is MATS, MATS is MATS. Two different book. State clearly, okay, this is our chapter 1 function. Okay, now this one, let's recall what we have learned in the lower form, the relation. Okay, the relation when two set of values are connected together, just like our x and y, so that's called relation. So this is the one that we always see, arrow diagram seen before, right? Okay, so the first group is called X. The second group, we always call it Y. So the first group we call the group of, in science we say this is manipulating variable. Y, the second group that correspond, it will be the responding variable. So this is MV, this is the RV. But that one is in the terminology of science. In maths, right, the first group we call it the set of domain. Okay, so this is the terms, the first set we call domain, the second set correspond to the first set, so it's called codomain. And then the elements, the members inside the domain, they are called objects, and the corresponding variables, the corresponding elements to the objects are called images. Then what about C and D? Well, it is not. Okay, C and D are not images because they are not related. They are not corresponded to the object. So it's there, yet it does not belong to the set of images. Are you okay? So remember the terminology: domain, codomain, object, images. Now object refer to the element, so you just write 1, 2, 3. You don't write now. The set X refer to the domain, refer to the set. So when you write the set, you have to use the cursive bracket, the set notation. Okay, the set notation. So in this case, let's write the domain. The set of domain, how should you write? The set of domain is like this. This is the domain. You must have the cursive bracket. Okay, you must have the cursive bracket with the objects inside. Then what about the codomain? Codomain refer to the set of second group. So all your second group elements must be written in your codomain. Okay? Can you see that? The most important thing is the set notation. Next, the objects refer to the elements in the first group, 1, 2, 3. And then the images refer to the corresponding elements to your object, only A and B. So even though codomain we write A, B, C, D, but in this case our images is only A, B. Can? Then the A, B, if we put in a group, we call it the set of range. So range, domain, codomain, they are set. Okay? D, C, R, are set. But when the question asks for objects and images, you only write 1, 2, 3 and A and B without the set, the cursive bracket. If you write cursive bracket wrong, no marks for you. So be careful. Okay? Yes. Object and images just refer to the elements. So not in group. Only D, C and R, they are set, so you must have the cursive bracket. So no cursive bracket for the objects and image. Are you okay? Right. Now, we're still in a relation. So apart from the arrow diagram where we can tell the object, the images, the set of the domain, the set of codomain, we can also look at the relation between two set of items by using the ordered pairs. So ordered pairs basically is set of coordinates. That's why you see cursive bracket. As long as it's a set, we always write with cursive bracket and the coordinates inside. Okay? Now, next, let's find the value of y. So how do I know what is y? Now, you look at all the x value and the y values here. This is x, x1, y1. This is x2, y2, x3, y3, x4, y4, x5, y5. Okay? Then you see x and y, how are they related? You can also transfer it back to the arrow diagram. -1 map onto -2. And then 0 map onto 0, 2 map onto 4, 3 map onto 6, and then 5 will map onto what is the number here. So this is also, I can also transfer the arrow diagram. I can also form the arrow diagram from the ordered pairs. So by the look at it, how are they related and what is the value of y? What do you think y is?
10.
Yes, it's 10. How do you know it's 10? Because this set basically times 2. Then you get the value on the second group. So the answer is 10. So y equals to 10. How do you get 10? 5 times 2, 10. Then state the type of relation. What kind of relation is this?
1 to 1.
Yes, it's 1 to 1 because by the arrow diagram it's so obvious. 1 to 1. Now write the relation by using the function notation. Function notation means the function x, fx equals to 1, or you do like this. The f map all our object onto 2x. This is the function notation. Or you write y equals to 2x, or we write fx equals to 2x. Okay? So we use a lot y equals to fx. Y equals to fx, what we have learned in the normal maths, isn't it? Okay, so it's either you write the first line or the second line. Both acceptable. Okay? Right. And then this one. I don't understand why is it so. Okay. Now, apart from arrow diagram, ordered pairs, we can also use the graph to show the relation between the x and the y. So in this case, what is the function, what is the type of relation between x and y for our domain -2 to 2 such that our x are real number? Real number means all your integers, non-integers, irrational number, all in. Okay, but your x will be from -2 to 2. So between this is how your y, can you see that? This is how your y changes. Okay, from 4 go down to 0, and then go up again to 4. Can you see that?
Yeah.
So state the type of relation for this. What kind of relation is this? Is it one to one, one to many to one, or many to many?
1 to 1.
Hmm?
1 to 1.
Can it be one to one? The moment I put this one 2 map onto 4, I have negative 2 map onto the 4.
Oh, many to 1.
Yeah, by just 2 specific number you already see cannot be 1 to 1. So this is many to 1. This is many to 1. Okay? Now write the range in set notation for the domain. Okay, we need to write the range. Range means all the images, the collection of images. The collection images in set notation for the domain given. So how should I write? It say for set notation.
X equals to 2x.
Where go 2x? That one's the equation, no? But I want the range. Range means the y values from small to big.
Negative 2. Small to big.
Need to write the range. What is range?
Range is
Set of images. Images is always refer to the y.
oh,
What are your y values from what to what?
2 and 4.
Why is it 2 and 4? Y values. Oh. You look at your y-axis, y values. Also look at y-axis. What are your y's? You see over here your y is 4. This is 4. Then all these also got, what are the y's here? The lowest that it goes is, the smallest y that you see from this graph is, okay, wait a minute. Do you know how to see the y?
X, Y.
The y-axis, right?
Yeah.
So the graph is from here and then go up again, right? That means your y value changes from 4 maybe to 3.99, 3.6, 3.1, 3.2, sorry, then 2, 3, 3, 2, 1, 0, then increase again, right? The maximum that you can go is 4 again.
4.
So what is the range of our, from this graph, what is the range?
4.
Range must be from, you know, a value, a few values, small to big. What is the smallest y here? Small y is 4. That means there are some more bigger than, because you say the smallest is 4.
Yeah.
It means your y is 4 and above.
No.
4 is not the maximum. Small is not the minimum. In fact, you never go beyond 4. So what are your range?
1, 2, 3.
The lowest that you can go is on this line, right?
Yeah.
What is the value of y here?
0.
Yeah, 0. Then as you go 0.1, 0.2, 0.3, 0.4, 0.5, then 1, 1.2, 1.3, 1.4, okay, 1.5, until 2, 2 all the way in between until 3, 3 all the way until 4. Can you tell me what is your range?
0 to 4.
Yeah, 0 to 4. What is 0 to 4? And we have to write the set notation way. It's like this. Our range consists of, okay, it's a set of y. It's a set of y. This symbol means such as y in between 0 and 4, and y are real numbers. Okay? I cannot write 0, 1, 2, 3, 4 because the number in between is also inclusive. How do I know it's inclusive? The biggest y is 4. Let's say this is 2. This is 3. Okay, 3 is here. But this point are also in. And this point, if you refer to your y-axis, it is the values in between the 3 and 4, including the decimals and all those stuff. So that is why your R, they are real numbers. All the numbers that in our number system. Rational number, complex number. Sorry, not complex number. Yeah, the real number. All the numbers that we use in the real world. No imaginary number. All real. Okay? So that's the answer. Or you may write like this. Fx range in between 0 and 4. But because it say I need it to be in the set notation, so I have to put like this. Consists of the y values such that y in between 0 to 4. So if you are looking for range, you look at the y corresponding y value, go to the maximum and also go down to the minimum. So our range will be in between the minimum and the maximum. Are you okay? Sure.
But I want to ask, why is there like the E?
This one belongs to. It's just a symbol. This is subset. This is the symbol of subset. But if we put this one, that means this is the element of. For example, if you have the set like this is A and this is B, so inside got 1, 2 and then 3, then we say B subset to A. Okay, set B, the element 1 and 2, it belongs to set A. I mean subset to set A, a small group of set A. This is a symbol of subset. Elements will be like this. The elements 1 and 2 are the elements of B. 1 and 2, they are also the element of A. Okay? So this symbol with the small dash inside, small dash refer to the member inside. It's so the whole symbol is read as element of. Element of. So can I write like this? 3 is the element of A or B? Which one? Three is the element of what?
3 is the element of B.
3 is the element of B, but 3 is not inside B. Element means the member inside. 1 and 2 are the member inside the B. 1 and 2 are also the member inside the A. So the 3 is the member inside of
AB.
huh?
AB.
Is 3 inside the B? Not at all. Then why you want to mention the B? 3 inside the other the bigger group lah, 3 inside the A. Okay?
Oh. Oh.
Right?
Okay.
So do you understand this one?
Yeah. Yeah.
Okay? Now the last part. State the object for the image for this domain. So what is the object of image 4?
0
What are the objects when your image is 4? What is image? Image refer to y. That means when your y value is 4, what are your x?
negative 2 to 2.
Negative 2 to 2?
Yeah.
You mean all the answer in between also acceptable? Then when your y is 4, what is the x value? What are the object? Object means x. What are your x?
0 to 2.
0 to 2 means here. That means all these are in also. When all these are in, that means all these points are in. In. But I want my y equals to 4. When is it y equals to 4? When is it y equals to 4? This line lah. On this line, y equals to 4. So what is your x value? What is your x value when y equals to 4? What is your x value when y equals to 4? Is there any point of intersection between the straight line and the curve?
No.
No point of intersection. Point of intersection means, does the straight line cut the curve?
Yes.
Cut at how many points?
0.
0 points, so it's not cutting anything.
It's cutting.
How many points that it cut?
2 points.
2 points. Which 2 points? This one, right?
Yes.
And this one, right?
Yeah.
So what are your x value? The value of x equals to
2
and
and
4 is y.
4 and 2 and negative 2.
Yes.
Oh.
What is your doubt just now?
Huh?
What is your doubt?
I misunderstood the graph.
What do you mean by you misunderstood the graph? You don't know how to read the graph, is it?
Yeah.
Is it I scribble too many things that you don't know how to read? Or you memang, right, no matter what happened, you also don't know how to read?
I just do not see the graph.
Okay, now let's look at the graph. When we draw the graph, right, which part is important? I mean, in this case, right, after I draw, right, which part of the graph is we use to get information?
The points.
Which point?
The 2 points.
These 2 points? What about this curve? The curve is also part of the graph, right?
Yeah.
Can I say that all the curve is actually formed when if you know all the points, you plot, 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 and then you join them to the extent that you form that curve? correct?
Yeah.
Which means you are only active between this region, correct? Along the x-axis, the corresponding x value is from here to here, only this part. Agree?
Yes.
Then after we study about the x-axis, what about the y-axis, from where to where?
Y-axis
The y-axis, yeah.
from where?
From where to where should we look into? Are we looking at the whole y-axis?
No.
No. Then from where to where we are looking at the y-axis?
From the y-intercept.
Y-intercept means here, the minimum point of the curve. What is the y value here?
4.
The y value here,
Oh.
the y value here is 4,
0.
0. Because on x-axis, y equals to 0. And then your y keep increasing, right?
Yeah.
As you go out of the 0. So what are your y values?
Now
Yeah, what are all your y values?
0 to 4.
Yeah, 0 to 4, because the maximum here is 4. Basically, this box is the region that we look into when we study the graph. So our y range from y equals to 0 to y equals to 4. Isn't it? This will be your range.
Yes.
Okay?
Okay.
So, understand the graph now? Did you copy this? Haven't. The previous one, did you copy?
Call down copy.
Oh, okay.
Done.
Okay. Right. So the type of relation, this is what we have learned before. One to one, many to one, many to many, one to many. You know how to identify, right?
Yeah.
Okay, so this one we can skip. Now, but anyway, many to one, you will have the symbol of like this, minimum 2 to 1. You may have 3 to 1, 4 to 1, doesn't matter, but minimum you must see this. One to many, it's like a greater than graph, a less than, greater than symbol and less than symbol. Then many to many, you will have this, like someone closing his eyes. Okay, then you have many to many. Okay, have we done this before?
This one.
Yeah.
I thought you just started.
Okay. A function is a relation. This is the definition of function, yeah? Where each and every object has only one image. Each and every object has only one image. For the following diagram, okay, please decide whether they are function or not function and justify. Now, out of the so many relation just now, one to one, many to one, many to one to many to many, only the one that has one image, they are function.
Oh.
Okay? One to one and many to one relation are functions. So in that case, can you try to determine diagram I function or not function, and reason. Give reason. Let's say it is a function. Reason, because each and every object has only one image. Only one image. Okay? If it is not, some of the object has 2 images or 3 images. You explain like this. Okay? So part 1, part 2, part 3 until part 5. Can you answer now? Yes or no? Both also give reason.
Why all is on function? Why it is all functional?
All not all are function, Not all are function. It must fulfill the definition. Each and every object has only one image.
Okay.
Right. The first one is a function. Okay? Because each and every object has only one image. What about part 2? Is that a function?
Yes.
Yes, the reason each and every object has only one image. Part 3. Is part 3 a function?
Yes.
Why?
Each and every object has only one image.
You listen to what you say. You say each and every object has only one image. Does C has any image?
No.
Then will that be a function? It doesn't fulfill the requirement whereby each and every object. Why do I highlight it?
Oh.
So diagram 3 is not a function because object C has no image. It's like a human standing in front of the mirror but cannot see his own reflection. Will that happen? By any chance, will that happen in our real life?
No.
No. So this is not a function. If that really happened, it's not a function.
Okay.
You will be malfunction also. You'll be scared to death also. Very scary, isn't it? You stand beside your friend, and your friend has no image, but you have image. Correct. Okay. So diagram 3 is not a function because object C has no image. What about diagram 4? Is that a function?
No,
Why?
because there's more than one image.
Yes, correct. Because A has more than one image. A has 2 images. Okay? Diagram 5, is that a function?
Yes,
Why?
each and every object has only one image.
Yes. You can also say because it's a many-to-one relation. Acceptable also. You can also say each and every object has only one image. Okay. But if you answer because it is one-to-one function, is one-to-one relation or many-to-one relation, that means you are taking the second definition. You answer like that also can. So make sure you copy the diagram and copy the answer. Highlight the diagram 3. This is the tricky one. To trick you whether you read your definition or not. But is the question look difficult? No, it's not difficult. All these actually test your basic. Understand? They all test your basic. So MS and MS which emphasize more on basic. Alright? Never mind about how the question they ask, because everything that they ask, they will have a one general framework. So to master the topic, you got to build your framework firmly. The framework is your concept. Okay, right. So the representation of function, we already learned the arrow diagram, the ordered pairs, and the graph. Add 2 more, the equation itself, and the tables of values. This is more like a scientific experiment. We record the data. So we have MV and RV. This is also another way to represent a function. Okay, done, this one.
Oh, okay. Ah, I'm supposed to copy.
You don't want to copy also can. It's not really important. Just let you know lah. Representation of function. This one you have done. We have done before. In Form 3.
Oh,
Do we?
I think.
Okay, never mind. These are graph function. Okay, graph function. I think it's Form 3 under graph function. So it write y equals to ax to the power n. So when your n is 1, this is when your n is 1, yeah? This is when your n is 2. This is when your n is 3. N is 4. 4. Negative 1. When your n is negative 2. And negative 1 basically is y equals to 1 over x. This one is y equals to 1 over x squared. We call this reciprocal graph. Whereas this one is reciprocal quadratic. How to write this? Okay, function. This is reciprocal function. This one is cubic function. What's the name for this when n is equals to 2?
Equals to that.
Yeah. This kind of function, what is the name? What kind of function is this?
The small graph.
Yeah, what do you call this? Like this is called cubic function. This one is?
The smiley graph, what do you call it?
Yeah. The parabolic graph, we call this quadratic.
Oh, quadratic.
This one? What kind of function is this? Start with L. When it is a straight line, we call this what kind of function? We have quadratic function, cubic function, reciprocal function. This one, L what?
Linear.
Yes, linear function. Linear function. Okay? Right. Hey, this one important, huh? Yes, important. Now, generally is y equals to ax to the power of n, right? So when the value of a is positive, this one is y equals to ax. Okay, this one is, there must be an a there. This one is a over x. This one is a over x squared. Okay? Now, what is the value of a? It can be any value when your a is positive. You have this kind of graph, straight line graph. When your a is negative, the graph will be going downhill. When it is positive, it's going uphill. Then this one will go downhill. How do I know go up or down? Isn't it if I look this way, if I look this way, this one, then I can say go down, so what? Correct or not? But when we say up or down, it depends on from small x to big X. From small x to big X, right? That means we only move this direction, right? So as we move this direction, the blue one is getting higher and higher, higher and higher. When we move this left to right direction, you see the red line is getting lower and lower and lower.
Yeah.
You understand? I have to set the direction of motion, yeah? It's going towards the right side. Follow the arrow of your x-axis. So in this direction, the blue one is going uphill, the red one is going downhill. So going uphill is represented by the number in front, positive. The number in front of your variable x is negative, that means it's going downhill. Is that okay? Now this one, same thing. If your A is negative, then the graph, instead of going up, is actually become a sad face. Okay? Okay. Now, all this that you see here, they are all A positive. Okay, so again for this one, as we move from left to right, isn't it the graph going up and up?
Yeah.
So now, can you guess when A is negative? The graph basically reflects along the y-axis. This is our graph when your A is negative. And this one, when A is negative, what happened?
It's like a star.
Yeah. It's a reflection on the y-axis. And this one, when your A is negative, where should I write? So it will be a reflection here. Can you see the tip of the pen? Okay. This one kind of important, yeah. So can you copy in your book? Put them together so you can make your book horizontal or whatsoever. Okay. The important stuff is you must know when your n power, when the power is 1, 2, 3, -1, -2, how does the graph look like? So at least you know, oh, the graph look like this. So every time you see a 5x squared, or you're expecting a smiley face graph. Okay, now to test whether this is a function or not, of course we know this is a function. These are the graph of function. That's why they are function. But how do we show that, prove that it is the function? We shall use the vertical line test. Now you draw a vertical line. Okay, as you glide through your vertical line across the graph, take note. You notice that you look at the blue lines and the blue lines only, and the red lines after that we add on one. You always touch the blue line at any time, only one point. Can you see that? Ignore the red line. Okay, ignore the red line. You notice that if I were to glide through drawing using the vertical line, we call this vertical line test. Look at the vertical line and the blue graph, the graph of function in blue. Every time, at any moment, it only intersects with the blue line at one point.
Oh, yeah.
Right? And this vertical line test proof that they are function. So remember, we use the vertical line test to test whether it is a function or not. Alright? So this one, please write down, because I want to highlight vertical line. You write like this. Vertical line, you write like this. Isn't it? This is the way we write our f. So vertical line is actually for us to test whether it is a function or not. Does that mean we have a horizontal line test? Yes, of course. Horizontal line test. You draw horizontal line. Isn't it? This is the first stroke that we write our I. So we use the horizontal line test if the graph has inverse or not. To test inverse. Okay, the vertical line is to test if it is a function. Okay? To test if it is a function. Okay? So you see, if I draw the vertical line, the horizontal line, you notice that maybe the linear function as you glide down, it only cut at one point. So this linear function has inverse. But the quadratic function, if I draw a horizontal line, it cut at 2 points. That shows what, you know? Quadratic function has no inverse. Quadratic function has no inverse unless we erase this part. Unless we don't want this part. We set the we set a condition that, okay, only when x greater, that we only take this part. Set the condition when this part, yes, anytime the graph cut at only 1 point, then this function has inverse. The last one also the same thing. I have to set this apart. That means I take x greater than 1 so that it will become a function that has inverse. So this one got inverse now, no issue. This one got inverse, no issue. Okay? So next, we shall go to the function notation. Right? Again, we start with the two groups. The first group is our object, x. The second group is our image y. Isn't it? This is what we used to learn in lower form,
Yeah.
x and the y. Now I use the arrow to put them together. How do we read this, the meaning of this diagram? We read it as f map the x onto y. And we write like this, f f map the x, f map the x onto y. Okay, and then, but this one, when we want to solve, right, in maths, right, it has to be always in equation form. So how? So I change it to equation, and this is how we change the equation. Fx means the function in terms of x. The function in terms of x is equivalent to y. Okay? We used to write y equals to 3x plus 5. Now instead of writing y, I just replace with fx only. So fx and y, they are equivalent. Just a different way of writing. Okay? For example, your name is Aiden. Your mom call you other name at home, but it's still you. Okay? So the f map the function x equals to y. I just replace something else, but they are the same. They're still the same. Now, so if you are given the function where f map the x onto x squared minus 5x plus 2. Actually, what does that mean? Now, function is just like a program that we preset, such that whatever ingredient that you put in, that's the reason we write like this, is that I have a program f. You throw in the x, I shall come out, produce by squaring the x, multiplying negative 5 to the x, and then put them together, I add the 2. Are you okay? In terms of diagram, if this is the production line, I have a program. My program is such that under this program f, when my x come in along this belt, it will be done concurrently two things. One is being squared, so that you come out square. And at the same time, I multiply. And when you come out of the production belt, it will become negative 5x. So whatever things that I put in, you square the x, you times negative 5 to the x, so you got this, and these two will combine. It will pass through the last belt, whereby you plus 2. Okay, this is what it means. Fx equals to x squared minus 5x plus 2. Like just now, if I use fx equals to 3x minus 5, what does that mean? If this is in the production line in the factory, the x goes in, we times 3 first. And after that, continue, you minus 5. Understand?
Why times 3 first?
Oh, the x goes in what? You got to times 3 first, no?
Oh, okay.
This one done first. You cannot minus 5 first. After you minus 5, you come out, this one will become x minus 5. Then the whole thing you times 3, then it will be 3 times x minus 5. So totally different. Yeah. So you got two things, you got to go through two objects, two boxes. Okay? But in Form 4, we don't do this. We don't draw, but drawing is for you to understand actually what happened. Okay, actually what happened. So let me erase this part and show you. If I have x, okay, I have to rewrite in the equation form. This one is the, the function notation. F map the x onto x squared minus 5x plus 2. But when we want to solve anything, it has to be in equation. So this is how we write the equation, such that y equals to fx. Instead of keep using y, I just write fx. Why? Because I can change the unit inside, I can change the object inside. The moment I change my x to v, all the x that you see in the formula will turn into v also. So v squared minus 5v plus 2. So what if I put t? I've got t squared minus 5t plus 2. Isn't it? It's the same. Your production line is the same. I put a star in. Star squared minus 5 star plus 2. Right? I put a musical notes in. It will be musical notes square minus 5 musical notes plus 2. Can you see the framework? The framework is such that whatever things that goes in, it will be object square minus 5 times object plus 2. This is what I meant by the framework. So when you do function, whatever things that they give you is a complicated item inside. Let's write the framework first. Now, when framework is ready, we put in the object. My object now is x squared. So every time when you see the bracket, you put x squared and x squared. This method will reduce a lot of careless mistake because the student will start to confuse x squared when they do manually, or they do without writing the framework. Then they will write like this: fx squared they forgot that the x squared is not your object x squared, you know. It's your object that put in, you gotta square it. Where don't care whether your original object is already square or not square. You're supposed to square whatever object that put in. But if you don't do like this, writing the framework, a lot of students will make mistake like this. Okay, so that is my method for you to avoid mistake that always every year I tell you, sure got 30% of the student will confuse this kind of thing. They're confused, they don't know what is function. They are confused. Use the framework to help you. Can you find the answer for this? Remember to expand and simplify. Copy this.
Copy.
Copy already.
This one.
Everything now, of course, then only can link to the last part that I want you to do. When you want to do the revision, you don't never do revision one. That's why you copy the notes for no wonder you copy in the random book, because you never look back.
This is a new book.
This is a new book. But my maths also you write in a random book.
So that was math.
But how come you start in the middle of the page?
This one.
Not the brand new page.
The cover keyboard.
Okay, then can. Alright.
The cover keyboard.
No combining, maths book, and maths book. So, and then very tidy, so that when you do revision, then it's easy. You know where do I come from? All these basically lead you to be able to write this, to let you know how do we apply the function. I have to.
这家餐厅的年代其实是比较久远的，晚上我们可以去尝一尝。宁总，好久不见，没想到能在这儿见到您。王总，
So what's your answer? Please make sure you expand also. Did you expand?
Have to expand also.
Yes lah.
So I have to solve it also. Like the
Soft? Where got soft? Just expand only. I see. See?
wait now. Counting the maximum expand.
爸有想几点回来吗？
没有诶，还有跟你讲吗？差不多了嘞。
没有，他跟我讲。啊，那刚刚我一直在。
Is that easy?
那刚刚我在楼上很久，我用 Photoshop 用到很爽。
Hey, the negative 5 times with the 5 is negative 25. This one is negative 25. Your sign, don't forget. Once you put in here x plus 5 minus x plus 5, you open up the bracket. You have x squared plus 25x. Sorry, it's not 25x. 10x plus 25. Negative 5 times x is negative 5x. Negative 5 times positive 5 is negative 25 plus 2. Are you okay? You expand this one, x squared plus 2 times x times 5. That's the expansion. Because x plus 5 times x plus 5. So you do like this, x times 5x. So you have x squared plus 5x. And then 5x again times 5. So you plus 5x times 25. The x times 5 and 5 times x basically is the same product. that happen twice, that is the reason your formula is always x squared plus 2 times a times b plus b squared. Yeah, the formula a plus b squared, it is always a squared plus 2ab plus b squared. Use this. If it is minus, then it will be a squared minus 2ab plus b squared. Use this formula to expand. That's why in your lower form, I keep encouraging you to use this formula. Don't use this expansion so long. Correct or not? Right? So, but you got to keep practicing on this lah, so that you will get is plus 10x, not 25x.
I don't multiply, I see how.
So x squared. Now plus 10x minus 5x here, so we have the net of 5x. Plus 25 minus 25, no more, left with just plus 2. So this is the answer. So be careful when you do the expansion. Okay, now, so given the function, so now you understand how it works, yeah? Right, so now you're given this function, you are asked to find this. How do you do? So you look at the question, I have fx. Now, of course, these functions are in function notation. If can always rewrite it, you want to copy, don't copy the question, yeah? Copy like this. Number 1, I have fx, straight away go to the equation. I have gx, I have hx. You understand? This is how we do maths. Copy the question without copy the whole question. Just take the important stuff. So instead of copying this, go straight to this lah. After all, we are using this in terms of equation. Now answer the question. I want to find f6. So this one we are using which program? Program F. Then you look at the program F. What does F say? F say for every object that given, we shall take that object plus 2.
So 6 plus 2.
Yeah.
Oh,
So that's how we do. And B, we want to find G2. So you look at program G. What does program G say? And write its framework. Write its framework. Yeah? Program G say whatever object that put in, you shall take that object to square it and minus 3 times that object. So what's your object here? It's 2. Then you fill in the 2. Can you see that? Write the framework, fill in the object later, then focus in calculation. 2 squared, which is 4, minus 3 times 2, 6. So the answer is negative 2. So your G2 is negative 2. F6 equals to 8. Make it a habit that your last line is filled with your left hand side, title, and right hand side, your answer. Okay? I do not know from which year onwards they are very particular that your final line must be left hand side and right hand side completed. Cannot just leave it like what I did just now. That means you cannot just leave it like this. It's considered like don't know what you are looking for. So you must have the left hand side and the right hand side. Is that okay?
yeah.
So likewise, can you do C?
How about the C? C?
Yeah, sine 2x.
How do you do the C?
Exactly the same lah. First of all, you want to find H15, write down first, write down the writing, write down first. What does function h say? Function h says sine 2x. Sine copy. X is the object, right? What is the object? Put in.
15
Yeah, 15 degree.
degree. I just type in computer.
Yeah, correct.
Oh, like that.
Yeah, yes. It's just like that. Put in. So what is sine 30?
Sine 30. One over 2.
Yes, 1 over 2. Okay. Now, that is C. D and E, we need to find the value of x when, okay? They give us an equation. Fx equals to 8. Then we start with the equation. Already got left side and the right side. The next line shall be, can we replace the left hand side with something equivalent? We have to use the fx. What is fx?
6.
Fx, not f6. What is your fx? What does function fx say? It say x plus 2. So we replace it with x plus 2 equals to 8. So we form an equation. Can we find x?
Yes.
Yes. How do you find x?
Throw the
Correct. So you become?
4. 6.
Yes, 6. Because it's 8 minus 2. So x equals to 6. Next, the E. E, they want us to find the range of your fx when your x is from 0 to 5. Now you see fx is a straight line, isn't it? It's a linear graph, correct or not?
Yeah.
How does the graph look like? Going uphill or downhill?
Uphill.
Uphill. And then you see plus 2, right? The y-intercept is 2. Roughly like this. But now I only want my x in between 0 and 5. It means when it is 0, it's here onwards. Correct or not?
Yeah.
Okay? So I need to find out what is my fx value when x equals to 5 lah. Let's find when x is 5, what is the fx value? So you have to refer to program f. What does f say? F say object plus 2. So object is 5. So 5 plus 2. So I got 7. So the coordinates here will be 5, 7. That means your y value, this is the maximum already. Your maximum y is 7. Your minimum y is?
Y is 7.
This is 7.
Yeah.
At this position, do you think it's maximum or minimum?
Maximum.
Yeah, minimum is?
2.
Yeah. Therefore, the range of fx, the fx range in between 2 and 7. That's the answer. Okay? Understand on this part E?
Yeah.
Okay? Right. You copy this one first. How do you copy? You just write number 2, fx equals to a over x plus b. Then you draw the arrow diagram. You see the word like arrow diagram represent, right? No need to copy. I just want you to copy the important stuff. Okay? Or don't have to draw this arrow diagram also can. Just write this. The f map 1 onto 2. and the F map -2 onto 5.
Oh.
You must know how to read the arrow diagram and write it using the symbol. So under the F, the X, because Fx equals to A over X plus B, right? So this line, your X is 1, the other side is 2. So it will be F1 equals to 2. And then for this line, your left hand side is -2, your right hand side is 5. So F map -2 onto 5. Understand? Okay, so can you copy this one first? Number 2, copy this. Then A, you got to find A and B. And then B, you got to find X when Fx is undefined. Copy first, then go back and try. See the image of X. So if this is the image, that means X, this must be the object. So when X equals to 6, you are looking for the image. Right? The object that has the image, that means your Fx is -5. Wait, Zach, you really have your good time from morning till now. Yeah, after you copy, then you can go already. Aiya, my phone is here. I think you can do the A and the B. You may not be able to do it. It can, I think can. What does it mean by undefined? Undefined means you can infinity. You cannot get the answer. Okay. All right. Bye. See you. Hello. Where did we stop actually?